Okay, let's continue watching the video of the on-site interview example.
All right. What I want to do is some kind of array or sweep line algorithm to run and create some events. So what I want to do, it's at first I want to sort all points on. Let's see. We're not able to move a camera. Let's imagine that.
Yes, camera center is fixed.
Yeah, so we can subtract center from each point. So we have a camera in
That's good.
here and a lot of points
Yes.
around us. So
Okay.
we not need care about the camera position and so on.
Okay.
So and we have only one value. It's our angle.
Mhm.
So we also can a bit make problem easier. We don't. We would like not see not to find this angle with the center. We want to find this one. So I mean the result will be the result will be angle, right?
Yes.
So a result will be a center angle of
Yes,
this
yes, a center
one.
angle.
So I want to make it a bit easier. It will be not center. It will be left, like left ray.
Mhm,
So
mhm.
after that we can just add this value and return center. So
Two.
because we want to use this approach,
Okay.
it will be easier. So what I want to do is to at first sort all points by angle.
Okay.
Let it be counterclockwise.
Okay.
So there is different methods of sort. One of them is sort directly by angle. It's going to be like we need to use A10(2) of, for example, y of second point and x of second point less, or I mean first point, less than std A10(2). So if our points are double, so we not we can use only this approach. If positions of our points integer, it's better to use another approach. I mean, it's better to use cross products.
Yep.
So we need just to compare. If you want, we just see in which quarter this point, and at first we compare quarters in our comparison function.
Okay.
So if 2 points in one quarter, we just write let it be vector 1a, there's one vector b. So we need to write a cross product of these vectors. Like it will be that.
And then can you tell me what the cross product gives us?
Cross product gives signet area of this.
Yes. Yes.
So it gives our rotation on counterclockwise or clockwise. If cross product is positive, the vectors are counterclockwise.
Okay.
So we can use this approach. It will be pretty easy. X, it's multiplication. So this is a cross product of two vectors a and b, and if it positive, so these vectors are rotated one and so we can do this comparison, and it will work faster than a calculated tan of angle. But if we have doubles, we have only one way. It's using this one. So
Okay.
I
so,
just mentioned that we can better to solve this in as integer solution.
Okay, let's
So-
zoom out a little bit.
All
So,
right.
so again, can you elaborate what you are trying to do here?
I would like I don't know how to transfer this problem to linear problem.
Yes. Okay.
It's all
And
that
then
what-
from
what I-
this computation, for each point, what do you want to obtain? Like, do you want to obtain the angle, and for these points, you want to obtain this angle or any?
yeah, let it be just angle.
Okay, just angle. So, you
So
want,
we need to let's see about this one. I just want to mention that the integer solution also exists, and we can maybe probably
Integer
use it, but it
Okay.
will be much harder because
Yeah.
we need to
yes.
mention about.
So let's say the point here.
Mhm. Here you are.
Point here, you want to measure this angle, and
Mhm.
then I have used alpha, beta, and then let's say gamma, and then you want to measure for this point, you want to measure this gamma, right?
Mhm.
So for every point, you want to measure the angle reference to the x-axis.
Sure.
Okay, that's clear.
I would like to for each point measure the angle. For example, we can just there is we cannot compare vectors which is from left side from another side.
Mhm.
We just can for example,
Mhm.
if it's coding problem, we don't have enough time. I need to write some code, so we can put all angles into vector, for example, sort them and find such segment which will contain the most.
Okay, how about this? You have a function.
Sure.
So the input to the function is point, and then output is an angle.
Mm-hmm.
How about that? You are given the function.
Mm-hmm.
You don't need to implement it. It's already there. You can utilize them, and then you know how to solve those the functions. So let's say that you're going to convert this constant vector to the map. No, yeah, in any form, like a map of the points to angle type of thing.
Mm-hmm.
Or no, it shouldn't be vector. No, it should be inside a vector. So there's the vector of pair of the points and angle, and then you can sort this vector by angle,
Mm-hmm.
and then you are already given that. How about that?
Oh, all right.
Yeah, I just want to
If
simplify.
if it's given, it's okay.
Yeah. Let's say that vector
All right, got it.
or pair
Point. Mm-hmm.
point and
Angle.
double
Double angle. All right.
yeah angle, and then it is there.
Mm-hmm.
Point and angle. How about that? No,
Alright.
you already did something.
But and it's sorted, right?
Yeah, it's sorted. Yeah,
all right.
sorted by angle.
Mm-hmm.
Mhm.
All right. So we can. There is several approach. We can create like this solution. We just fix one element and go over to the right. But if it's a break, we just go from this side of array. So and we calculate how many points inside of this.
Oh, okay. So you're gonna visit every point for every angle, potential angle.
Yeah. So. My approach is I have two approaches.
Mhm.
One of them is let's see. This is all angle. We just cut it here.
Okay.
For example, this is
Okay.
one. So we want to iterate, and we have angles where we have a point. For
Yes,
example,
yes.
here we have 2 points.
Uh-huh.
Like this, and here we have only one, and here we have also one, and here we have like 2 points, and so on. So what we can do, we can just for example, let it be this approach.
Mhm.
We can just fix this one and try to find such angle which will be inside of our
Field of view.
field of view.
Yeah.
Yeah. So we find this one point. So field of view, right? So and we just calculate how many points here, and it's okay. Sorry, I thought that I'm too stupid in the morning. This is big O of n squared solution, and if we just move and try to do the same thing. First of them, we just convert this problem onto linear problem.
Yeah.
And after that try to use different approach for this problem. So I thought that this is pretty easy, we don't need to use it because it's time consuming. But if we have only 5 points, it's better to use this one because it's easiest way.
Yes, you're right.
So I
But
thought,
let's say that we have many million points.
yeah, if we have million points, I thought that it's better to use just loop over these positions and iterate and find like using binary search the last point which we can use. But it's also bad solution because there exists another algorithm which 2 pointers. We just move 2 pointers and try to follow this condition that it should be all the time. So and see how many points inside of this, and at the end we just take the best results. So
all right.
I can
Like
write some
you can
code if you
erase
want.
and you can erase something and then can you finish the coding?
Sure.
I think your algorithm works, and then 2-point algorithm will achieve of n complexity.
Yeah, it also works in big O of one memory. It's really good.
Yes.
No, because we need
because
to
angle.
use this one. Yeah,
You can use a pointer for this instead of point data set. You can use a pointer so that you can point to the elements here, input elements. So you do need to make a copy of points, and then.
If we have all elements sorted by angle, in this case we will use this memory.
No, I don't think so. Are you sure? You need a memory for storing the angles.
No, we can calculate if all points already sorted by angle, we are not able to store angle because we can calculate angle from direction of vector.
Yes.
We need to store only 2 things.
Yes.
It's a left bound, right bound, and the best answer.
Yes.
So it's going to be this solution. But in our case, let it be big O of n, and it's pretty easy and also good for.
There is no guarantee that the input points are sorted.
Yeah.
Points are just points, and then let's say that we have any sensor or any algorithm to the points,
of course.
Put them into this vector.
So in this case, just to sort, it's going to be this solution n log n because we need to sort something, and after that we can use the big O of n approach. So this is I need to code something because we have time, right?
So okay, that means that if your algorithm depends on the sorted points by angle, the overall complexity is n log n, right? Oh, so it is not n complexity.
But if they sorted, it will be n complexity and also big O of constant memory if it's sorted by angle. If it's not sorted, it will be n log n for sort them and n for store.
Yes, you're right. Okay. Again, let's say that there is no guarantee that input points are sorted.
Sure, we need to sort
so
them.
The algorithm will be n log n, memory will be n.
This array already given for us, we can use it or not.
Yeah, if you're given, if you have time, you can implement this side to make this, but I think it doesn't
I
add
don't
much.
know, have I time?
Let's say you are You have already computed, calculated this here.
All right.
Yeah, you already given that.
So,
and then this is already.
I guess here
this is
because
already,
we just
yeah.
we just stated this.
And then you can assume that this is something. Compute something. You already called those functions. It's already there.
All right. I need
And
to write compute function
later on.
After that.
Yeah.
All right. So we have. I need to see visual elements. This is a point. All right. So let it be. It's a int best result. Best result. For example, it's only 0 points. If we have a 0-point array, we don't have results.
Yeah,
and
right.
we can check, for example, if size. We return what we return? Angle.
Yeah.
So we need to write a check, or we need to write some kind of if our inputs points empty. We need to make assert or return some value which is more. So,
okay.
So, all right. So after that, we can maintain left bound. For example, if we have elements. So it's otherwise. So it will be in the left bound. That's this one, and actually we can use and right bound. Just let me think. Let it be like int right bound. Let it be here, and left bound we just go over this left bound for int left bound from 0 to the last element in this array point and angle point and angle. Oh, sorry. I need to left bound less than point and angle size. Or we can use C++. All right, never mind. Point and angle size and increase left bound. All right. So what we did right now, we just fix left bound, and we know that right bound it's at the first moment they are in the same position, and we just try to move right bound as right as possible. So it will be current result. Let it be here. I know it's not a good style, but int current result. Let me think. It will be. For example, we can. Let it be 0, but actually I need to check it because it's also possible that all elements here, it depends on the implementation.
So eventually you're going to return this. The current result.
It's my current result.
Yeah.
This will be best result. Will return best result.
I see.
I want to calculate this one. So
wait. You're going to return best results, right?
We will return best result.
Is it the counter or the angle?
Sorry. Yeah, it's just counter. So we need to also maintain a double best result angle.
Yeah, I see.
We will update this angle with this one.
I see.
All right. So. Okay.
You may have a seat here.
Not a problem.
If you want.
Thank you. we just need to we just move right angle distance. We can maintain helper function which will return the angle between two points, shortest angle.
Oh no, no,
No?
it doesn't need to be shortest.
Ah, yeah,
It is fixed.
Yeah, it's fixed.
Uh-huh.
Sure. So this is one, and second we need to calculate angle here, and like so it will be double angle between like between two angles, or it's like yeah, I don't know. So it will be or point or angle is will be double angle 1 and also double angle 2, and we need to return double angle 2 minus angle 1, but they can be less than 0, so we need to add 2 pi in this case. We
Yes.
have also several options. In this case, just
You're right. I understand.
we can use, for example, f mod function for, and in this case we can return only one line called return f mod std, or it doesn't matter, std, let it be f mod, like angle 2 minus angle 1 plus 2 multiply times pi, or pi times 2. We can use maths pi, and or we can define like
it's fine. Yeah.
r cos of minus 1, it doesn't matter. So and by 2 pi, model of 2 pi, right? Or no?
All right. Yep.
Or we can just check it.
I understand. I understand.
Right. So this is angle between two. So. All right. Let me think. We need to follow the condition that angle between 2 points, let it be angle between, less than or equal than our field of view, right? Field of view. So, so what we can do? Let's see. For example, while we can need to write a while loop, while we can move right bound. For example, if an angle, because I need to tell that at first moment they both in one position, so they have this condition also true, because field of view is impossible to be zero.
You're right.
For example, we can check here that the field of view, check grade GT, right? Yeah. Field of view is then 0.
Okay.
Because so angle between angles. Angles. So of this is our array point and angle. Point and angle. angle.
Okay, let's stop here. We're gonna keep watching the remaining parts in the next session.